So now let's parametrizing intersection of surfaces. We've seen this somewhat. We've discussed the different when we were trying to integrate different over different solids. We realized that drawing those solids, it's important to draw the intersection of the surfaces. Now let's parameterize those intersections. In example 4 is asking find a vector function r of t that parameterizes the curve of intersection of the cylinder x squared over a squared plus y squared over b squared equal to 1 and the plane x plus y plus z equal to 1. Now, if I remember from pre-calculus, this is just, even though this is the trace of the cylinder over xy plane, I know how to parameterize this in xy plane. So the first one, x is equal to a cosine of t, y equal to b sine of t, and then now I have to do z. I'm going to solve over there, and 1 minus a cosine of t minus b sine of t. And then this is a parameterization, so I can write it that way, or I can write it this way: a cosine of t, b sine of t, and 1 minus a cosine t minus b sine t. And that's the vector, that's r of t. Let's go somewhere with better handwriting. And so that's the, now I click a question 13.1c. Find a vector function that parameterizes the curve of intersection of the two surfaces defined by x squared plus y squared equal to 4 and z equal to x squared. So I suggest to pause and then come back. So hopefully you pause and you're coming back. Again, this is a circle. I know how to parameterize the circle, and one way to parameterize the circle is using the radius times cosine for x, and then radius times sine for y. What is the radius? Radius is 2. So I have multiple of these that can match. And let's see which one is the actual match. And these two are out because x equal to 4 cosine of theta is going to be too big, and y equal to 4 sine of theta is going to be too big. Now let's look at the two that are okay. These two, between these two. In here I have 2 cosine of theta, 2 sine of theta. That's matching this, but then z is supposed to be x to power 2 and it's not, so this one's out. Is this okay? Let's check. Z is 2 cosine of theta to power 2, and in here I see that it says negative 2 sine of t. Is that okay? Yeah, it's okay if you are actually switching t. If you switch, if you go from 2 cosine t and 2 sine t and 4 cosine squared t, and plug in negative t instead, and change the domain that way, then you will get 2 cosine of negative t, which is cosine of t, 2 sine of negative t, which is 2 negative sine of t, then negative 2 sine of t, and then cosine of, and the last one also stays the same. So different parameterization gives you different value, and B is the correct answer.